Okay, so we're just going to do a quick review of module number 7. Deals with data selection as well with model selection, I should say, as well as data splitting. So you just have to maybe pull back a little bit, right, with this whole model selection process. What are we thinking of? So there are two main uses of regression models. One is prediction, and the other one is to explore relationship between the response variable as well as multiple predictors simultaneously. So if you think about these two uses, right, really what, depending on which use you are more interested in, the way in which you view the model selection process can be a bit different. Because if you're truly interested in just prediction and not so much relationships between the variables, then, right, if you think about your regression framework, right, we say that your response equal to some function of x plus your error terms. Now, in prediction, the function of x, the exact form of what this could be, isn't really as important, right? All you care is if you put in your predictor variables, all you care is for your yi to be close to your yi, right? That's from a prediction standpoint. So that's all you care about. So in such a setting, the actual form of f sub x, you really don't care as much as long as yi hat is close to yi. Now, if your focus is more the second one, where you're exploring relationships, right, where you're trying to interpret coefficients, saying like, hey, if I, study an extra hour, how much do I expect my score to improve? That kind of relationships. Then the form of this f sub x is going to be important, because you want the form of your f sub x to be simple enough where those coefficients can be interpreted easily, right? We've already seen before that once you have higher order terms like interactions, the interpretations get a little bit more difficult. So the ease of interpreting, right, f of x, right, becomes more important, right? So typically you could think about this, right? Including more predictors or higher order terms can improve model fit, so will probably help improve prediction, but can also make the model much more difficult to interpret, right? So there's kind of this like balancing act you can do. Now, the one warning I have for you is, right, that making a model more complicated than needed can result in what we call overfitting. And overfitting leads to poor predictive performance on new data. That means if you make your model more complicated than it should be, then your prediction will perform poorly on new data as well. So you cannot just say, hey, let's just throw in all the predictors, make it as complicated as possible to improve the fit. Well, it gets to a point where the improvement in fit actually is not going to help improve the prediction for future data, right? So there's this balancing act that you have to do. So there are a few measures in which we can use to compare, right, our different potential models. So we talked about R-squared earlier on, right, and they should only be used when comparing models of the same size. When I say same size, means same number of parameters, right? We've seen that adding predictors or terms to a model will always increase R-squared, because the SSR increases and the SS residual decreases by the same amount. So kind of in response to this drawback, right, there are other measures such as what we call adjusted R-squared, Mallow CP, AIC, BIC, which are sometimes called penalized fit criteria as a whole. So why do we call these penalized fit criteria? Well, a penalty is added when an extra term is added to the model to improve the fit of the model. So for example, if you look at the formula for the AIC in a regression setting, this is the formula. We know that when we add a predictor, SS residual goes down. So this first term over here goes down, but the second term over here goes up, right? So this goes up, that goes down. So it's kind of this balancing act. You make it more complicated. So basically what we're looking at is the reduction in the SS residual worth the extra complexity in the model, right? And if you look at the formulas for the other measures like Mallow CP, BIC, that's the same framework. So these measures can be used to compare models when the partial F-test cannot be used, right? We say that the partial F-test can only be used if you have nested models, right? If you have non-nested models, then you can't use the partial F-test. Right, so that's just one thing to be aware of these different criteria. Some comments on automated search procedures, such as all possible regressions and forward-backward selection as well as stepwise regression. So these functions, so reg subsets performs all possible regressions. Step function performs forward selection, backward elimination, as well as stepwise regression. Now, a few things to be aware of. They only consider first order models, so they do not check for interactions or the need for higher order terms. These functions do not check if the regression assumptions are met. You still need to check the residual plot to assess whether the assumptions are met. These functions do not guarantee that the best model will be identified. Step function, so for forward, backward, and stepwise regression, they can lead to different models if you have a different starting point. And one thing to take note of, for the step function, R uses AIC to decide when to stop the search, whereas the textbook describes the procedure using the statistic. So generally speaking, these automated search procedures, I kind of use them as part of my toolbox, right, to maybe help me first identify which potential models I want to think about. But they're not the end all and be all, right? They're just part of the process, right? So sometimes you could use these to maybe help you decide, right? If you have a bunch of predictors, which one you want to use, you could do that first, and then kind of proceed along by producing the regression plots, residual plots to see if the assumptions are met. You can do other things, right, after that. So it's not the end product over here. Some comments on data splitting, right? So in data splitting, a data set is randomly split into two portions, the estimation data and the prediction data. So the one portion, the estimation data, are used to build the regression model, and then the prediction data are used to evaluate the predictive ability of the model. So this is kind of how we evaluate if we have overfitting, right? So we say that overfitting happens when you make your model too complicated, and as a result, it performs poorly on the quote-unquote new data. So in this case, to get the new data, we use a portion of our data as the prediction data. Now, if you are aware of these ideas, right, most of the times, these are called the training set and test set respectively, right? So that's the more common terminology, actually, that people use.